Welcome to class. Last lecture we talked about arithmetic expressions, and we noted that we could use the rules of precedence to actually compute a value for that arithmetic expression. Now in this lecture we're going to show that we can save that value in a variable. We're going to assign a name to that variable, and then we can use that variable in subsequent arithmetic expressions. Why would we want to do that? Well, there's a couple of reasons. First, if the expression was big and involved a complicated calculation, we might not want to actually do that again. So saving that value in a name avoids computing the same expression over and over. Second thing is, by giving this value a name, we can help the person that's looking at your code understand what your computation, your program is doing. So I'm going to walk you through a few examples of using variables inside your program to basically make your program more efficient or make it more understandable. Okay, let's do some examples.
So let's talk about variables. So a variable is a placeholder for storing a value. We want to store it to avoid recomputation or to give a value a name to help understand what it represents. In Python, valid variable names consist of combinations of letters, numbers, and the underscore character. That's this character right here. The name has to start with either a letter or an underscore. We'll talk about when you want to use underscore later in the class. The variable names are case sensitive. Typically for now you should start them with lowercase. And again, we'll tell you when to use uppercase conventionally later in the class. Here's some examples of things. Ninja, very nice variable name. Capital Ninja, pretty good variable name also, but don't use it till later in the class. Ninja underscore, 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 underscore. Great gamer name, maybe not so great Python name. Illegal names, a number, 1337. That actually has a meaning. It's called leet speak. 1 is an L, 3 is an E, 7 is a T. Leet. You can't be a leet ninja, unfortunately, at least not using numbers. If you want to have a multiple word name, variable name, it's fine. Just connect all the words using an underscore. That's Python convention. So for example, a legal name is Elite Ninja. If you want to even be more elite, you could be Leet Ninja. Or if you want to quantify your ninja-ness, you could say ninja underscore elite. Unfortunately, you still can't start with a number, so this is not going to work. How do you actually take that value and assign it to a variable? Well, you use equals. This is the same thing you did in, say, middle school algebra. You say variable equal value. Now notice that if you want to test to see if two values are equal, you use double equal. So single equal is assignment, double equal is equality testing. Now probably the most critical thing that you need to do whenever you want to go through and actually choose variable names is to think about something that's memorable, that'll help you understand what the variable represents. So for example, if I will go through and I say, up here I say M. Variable M, what does it represent? Not sure, but if I say my underscore name, I bet you can guess what that's going to be. It's going to be Joe Warren. So I could ask to print that out, print my name, run that. Sure enough, it's Joe Warren. I get another variable. I could say my age. My age, number, it's 51. Okay, so we've assigned some values to some variables. What can we do with them? Well, birthdays are fun. I actually had a birthday in February. So next February, I'll have another one. So what could I do? I could go through and update my age. How would I do that? Well, I could say something like my age is equal to 51 plus 1. Then I could print my age. So if I run that, it's going to be 52. Surprise, surprise. But notice this is kind of a foolish expression here because I already had my current age right up here in this variable my age. So in fact, what I should really set is something like my age is equal to my age plus 1. And notice that now works no matter what my current age is. It's always going to give me 1 more than the current age. Computations like this where I take a variable, I do something to it, and I update that same variable are actually so frequent that there's a shorthand that you can use in Python and again lots of other languages where you can use an operator which is called plus equal. So the plus equal operator takes the thing on the left-hand side, gets its value, takes this operator and applies it to the right-hand side, and then stuffs the value back into the left-hand side. So this does exactly the same thing. And again, it comes back with my age is equal to 52. Let's see, what's another one? Let's do one more example real quick. So I'm going to tell you a story about another variable, and this one may not seem to be exactly as understandable to begin with, but I'm going to have a variable called magic pill. And I'm going to print out my age minus the magic pill. So if I do that, I come back with, well, 22. All right, so let's go through and comment out this so we get the correct age. Get 21. So what is magic pill? So let me quickly tell you the story of the magic pill. So I have 3 children, 17, 15, and 12. My 15-year-old pronounced at one point that he was going to go through and invent a pill that took 30 years off your age. So he was going to give it away. So my oldest son said, wow, you know, that's not why you should sell that pill. You know, we could make a lot of money. So we had a long discussion about what the value of a pill that took 30 years off your age would be. And so we decided on $300,000. And so there was still some doubt from my 15-year-old that this was actually really worth $300,000. So he called his granddad. Now his granddad was $74. And he asked, Granddad, would you pay $300,000 for a pill that took 30 years off your age? And so Granddad had an interesting response, thought for a little bit, and he said, I'll take 2 of those pills. So let's print out what would happen if Granddad bought 2 pills. Be 14. I think it's a wise choice. So give your variable names memorable names. Give your variables memorable names. It'll help you when you go back and look at your program and other people go back and look at your program to understand what's going on. Okay, give me a sec.
So let's finish up with a more serious example that does something useful. So here I have in my comments, we'd like to convert from Fahrenheit to Celsius. So I've actually written down a formula here that kind of describes the conversion from a temperature F in Fahrenheit to a temperature C in Celsius. So let's just turn that into Python code. So what I'm going to do is I'm going to define a value for the Fahrenheit. So I'm going to be a little more deliberative here and actually give it a longer name. I'm going to call it temp Fahrenheit. And I'm going to initialize it to say, let's make it 32, because I think I know what the value of 32 Fahrenheit is in Celsius. And so then what do I need to do? I want to go through and write an expression that converts temp Fahrenheit into temperature in Celsius. So I could say temp Celsius is equal to, let's see, 5 ninths times, well, what are we going to use? It's going to be the temperature in Fahrenheit, so it's temp Fahrenheit minus 32, and then let's print out what the resulting temperature is. So we'll print temp. Now, one thing it's often good to do is when you type in a piece of code and you're testing it, instead of just typing values in and kind of running it and hoping that things come out right, it's often good to think, okay, what should the answer be before you run the code? So I said I knew the value of 32 degrees Fahrenheit in Celsius, and yes, that's 0 degrees Celsius. It's freezing. So let's see what comes out here if I run it. So good, came out. 32 Fahrenheit is 0 degrees Celsius. Now we also know that, let's see, 212 degrees Fahrenheit should be 100 degrees Celsius. So the value of writing this expression down here is that now we can just go through and change the value of Fahrenheit to be 212 and run it again, and if we're doing well, it comes out to be 100. Okay, let's do it the other way. Let's go through and write an expression that converts from Celsius to Fahrenheit. So we get one more little piece of practice. So I could say temp Celsius is equal to 0, and then I could write my expression that converts from Celsius to Fahrenheit. So temp Fahrenheit is equal to, well, let's see what my formula says. It says 9/5 times, well, temp Celsius plus 32. Then we could print temp Fahrenheit. So again, if the temperature is 0 degrees Celsius, we'd expect 32 degrees Fahrenheit. So sure enough, worked. Let's just do one more test real quick. It's always good to make at least do a couple of tests when we're building things. So if this temperature is 100 degrees Celsius, that's boiling, so that should be 212 degrees Fahrenheit. So sure enough, it worked. So those are a couple of examples of using variables to organize your computations. Now in our next lecture, we talk about more programming in Python. Scott's going to talk about functions, and he'll actually come back and revisit this example. I'll see you in a few more lectures.